Today I'd like to talk a little bit more about the squishy battery, and it's really simple. All you need is a piece of conductive dough and two different types of metal. This is a piece of copper wire, and this is a galvanized nail, which has zinc in it. You don't need copper wire. I just happen to have some of these lying around, and these are called grounding pigtails. Electricians use them. And I took this plastic coating off, and I was left with a nice piece of copper wire. So I ended up using these. But one of the easiest ways to get copper is to find a penny that's 1982 or older, because they're made out of 95% copper. In 1983 they switched to a different composition because it's cheaper, but at home a penny would work just as good as the wire would. Now, all you have to do is take your two pieces of wire, which we're going to call, or two pieces of metal, which we're going to call electrodes, and we're going to stick them into the dough, and we can hook up a voltmeter, and in a zinc and copper battery, the positive terminal will be the copper, and the negative will be the zinc. And you can see a voltage is present there. We have about 0.752 volts according to this meter. And the way this works is each metal has a different affinity for electrons, so it either wants to attract them or repel them. And the electricity is the flow of the electrons. So when you kind of complete the circuit with a voltmeter, or any other device really, you're allowing electrons to flow in a direction or be repelled in a direction, and that's how the voltage is generated. And that's why you need two different types of metals, is to create a difference in attraction or repulsion. So you can use different types of metal. The common ones are copper and zinc, but I've had success with paper clips and stainless steel. Not quite as good, but they work also. And feel free to experiment with different configurations and different types of metal at home. Now, this produces 0.75 or around 0.8 volts, but it won't really drive much or won't really power much because there's not a lot of available current, and honestly not that much power. When you think of voltage, when you think of a battery, that's 1.5 volts, and this is only about half of that. So what you can do is create a whole bunch of them and put them in series. So what I've done here is just taken conductive dough, an insulating dough, and another piece of conductive dough, and sandwiched them together, and I have a whole stack of them, whole long chain. And then I created just the same type of thing, two pieces of metal. I have a piece of copper wrapped around a piece of zinc or galvanized nail. And what I'm going to do is insert the nail into one piece of dough, bridge the insulating dough, and insert the copper into the next piece of conductive dough. And same thing, you're going to want to have, each piece of conductive dough is going to want to have one nail and one piece of copper. And so you just continue down the line, alternating. So now I have a long chain of squishy batteries all combined together in series. And I actually put the electrodes down here so it'd be a little easier to hook it up. One thing to keep in mind, a little tip, is if you let the metals touch inside the conductive dough, the squishy battery won't work. So you're going to want to make sure you have dough between the two different metals. And so I'm going to connect up a LED, and when you're doing this, you're going to want to use a red LED because red uses the least current and voltage. And here I just have conductive dough. Keep in mind polarity. You're going to want the negative terminal to go to the zinc, and the negative is the shorter terminal on your LED. And we have a dimly lit red LED. As you continue to increase the length or add more cells in series, you'd increase the voltage of your squishy battery. Now, if you combine these in parallel, you would allow the component you're feeding to have more current or power capabilities, which would, in this case, make the LED brighter. Keep in mind that you're probably not going to really power much besides LEDs with these squishy batteries. For example, a motor would take 60 sets of this squishy battery I have made here. So those are the basics of the squishy battery. If you have any questions or comments, feel free to contact us. Thank you so much for watching.